Hello my students, I'm your biology teacher, Chair Govin. Today I want to do sharing about answering techniques, biology paper 3. So in this video I want to give a tip how to answer biology paper 3 so that you can have a confidence in answering the questions. So I want to share the simplest, the easiest, the safest way to answer biology paper 3. Okay, important tip when answering question 1, paper 3. Read the question carefully and identify the followings: manipulated variables, responding variables, and constant variable. Underline it when you read the questions, when you already identify manipulated, responding, and constants. Okay, we focus on SPM question 2019, question number 1. Diffusion is a movement process of substances from the external surrounding of an organism that occur through the plasma membranes to fulfill the organism's basic needs. The rate of diffusions, okay, this one is, we underline it, this is the responding variables of substances depend on the surface area, this is manipulated variable, and volume of the cell. So this one is also manipulated variables. Diagram 1.1 show 4 pink agar cube of different size. So this is OMV, or we can operating manipulated variables, labeled as J, K, L, M, used in the experiments to study the effects of total surface area per volumes. This is manipulated variables on the rate of diffusion. This is RV. Okay, this is cube agar cube J. This is K, so this is L, and this is M, the highest, the biggest agar cube, and J is the smallest agar cubes. The following steps are carried out in these experiments. Step number 1, cube J is immersed in a beaker as shown in diagrams. Okay, this is cube J. Digital stopwatch is started immediately. Step number 3, the time taken for agar cube J to become colorless is recorded. And then step 4, step 1 until step 3 are repeated by using agar cube K, L, and M. So in this diagram you can see that the agar cube J is immersed in 6 ml of 2 molar hydrochloric acids. Table 1 shows the result of these experiments. Agar cube J, the total surface area per volume ratio is 1.2. Agar cube K, the total surface area per volume ratio is 0.6. Agar cube is operating manipulated variable. Total surface area per volume ratio also operating manipulated variable. Time taken for agar cube to become colorless, this one is operating responding variables. Okay, when you write your answer for observation later on, you must use operating manipulated variable, this one or this one, and connect it with this one. Okay, so the readings, you must write your reading in minutes. Okay, the answer is 2.5. You can give 1 decimal points or 2 decimal points, but if you give 1 decimal points, the next reading also must give 1 decimal points. You must uniform. This one is 9.9 or 9.90, 2 decimal point. If you write 2 decimal point, you must write 2 decimal points. Okay, don't mix it 1 and 2, 2 decimal points. Next, agar cube I, L, the surface area is 0.4. If agar cube M, the total surface area per volume ratio is 0.3. Okay, same also operating manipulated variables and operating responding variable. The reading is 20.1, okay, change in minutes. This one is 30 minutes, okay, this one easy, okay. Next, question B1. Based on table 1, state two different observations. Okay, from the table just now, operating manipulated variable is agar cube and total surface area per volume ratio. Operating responding variable is time taken for agar cube to become colorless or decolorized. And then when you write your observation, you must put the value and the unit. Okay, this is important. So this is the sample answer. When you write your observation, you must choose the best reading, which is highest and lowest, or fastest and the slowest. So easy for you to make inference or give the reason for your observations. Okay. So for this one, for agar cube J, the time taken for agar cube to become colorless is 2.5 minutes. Okay. Put the value and put the unit. Or you can write when the total surface area to volume ratio is 1.2, the time taken for agar cube to become colorless is 2.5 minutes. Observation number 2 also the same. Okay, this one is the slowest. For agar cube M's, the time taken for agar cube to become colorless is 30 minutes. Okay, value and unit you must put it. Okay, when the total surface area to volume ratio is 0.3, the time taken for agar cube to become colorless is 30 minutes. Okay. B2, state two inference which correspond to the observation in 1B1s. From questions, this is from question. 4 pink agar cube of different size, this is operating manipulated variable, labeled as J, K, L, and M used in experiments to study the effect of total surface area per volume ratio, MV, on the rate of diffusions. Okay, this is the RV. So when you write your inference, must have the RV. So MV and OMV is agar cubes, is big or small. The total surface area to volume ratio is small or big. Okay, when agar cube is big, the total surface area to volume ratio is small. When agar cube is small, the total surface area to volume ratio is big. Okay, and then the RV is rate of diffusion is low or high, depend on the agar cube, the size of agar cube. So this is the sample of answer. Number 1, when the agar cube is small, the rate of diffusion is high. Or you can say when the total surface area to volume of ratio is big, the rate of diffusion is high. Okay. Number 2, when the agar cube is big, the rate of diffusion is low. Or when the total surface area to volume ratio is small, the rate of diffusion is low. Okay. This is answer for inference. You must remember your inference must correspond with the observation. Okay. Observation number 1 must correspond with inference number 1. Okay. Inference number 2 must correspond with observation number 2. Question C. Complete table 2 based on the experiments, variables, method to handle the variables. Manipulated variable, the answer is size, volume, agar cube, or total surface area to volume ratio. Method to handle variable, use different size or use different volume or use different agar cube. Or you can write use different total surface area to volume ratio, or you write all the measurement for the total surface area to volume ratio. Responding variable, time taken for agar cube to become colorless or rate of diffusions. The answer for method to handle the variable, measure and record the time taken for agar cube to become colorless by using a stopwatch. You must start your answer with record. Okay, measure and record, count and record. Okay, or just record, depend on the experiment. For this experiment, you just record the time taken for agar cube to become colorless by using stopwatch. If the question need to measure using ruler, you must write measure and record. Okay. If experiment for photosynthesis, for example, you use hydrilla species, you need to count and record the air bubble release by using stopwatch. Okay. And then when you write the formula, rate of diffusion, you must give the formula. Okay. You must give the formula. Calculate the rate of diffusion by using, and then you must write the formula. Okay. Control variables, type of agar, volume of hydrochloric acids, or type of solutions. Method to handle, fixed type of agar use. Okay, the word fixed must. Volume of hydrochloric acid is fixed at 6 ml, must write it 6 ml. Fix the type of solution as hydrochloric acid. Okay. Next, D, state the hypothesis for the experiments. So the operating manipulated variable is agar cube and total surface area per volumes. The responding variable is rate of diffusion, or ORV is time taken for agar cube to become colorless. And relationship between these two variables must have the relationship operating manipulated variable and responding variable, or operating manipulated variable with operating responding variable. Okay, this is the sample answer. The smaller the agar cubes, the faster the rate of diffusion. Or you can write, the bigger the total surface area per volume, the higher the rate of diffusion. Or the bigger the total surface area per volume, the shorter or the less the time taken for the agar cube to become colorless. So this is the way how to write hypothesis. But not all hypotheses can write like this. The smaller, the faster, the bigger, the higher. But depend on the experiment. For example, vitamin C, okay, energy value, water pollution, you cannot write like this. You must compare it. For example, if experiment for vitamin C, lime juice contains high concentration of vitamin C compared to pineapple juice and orange juice. This is an example. So you need to compare it. Okay. For example, experiment for water pollution, you must say drain water is more polluted compared to the river water and lake water, for example. So you must compare it different with hypothesis for these experiments. Okay, if experiment for photosynthesis, respirations, or transpiration, you can use the higher, the lower, the higher. Okay, this one is different. Okay, next. Construct a table and record all the data collected from this experiment. Your table should have this following title: agar cube, total surface area per volume ratio, time taken for agar cube to become colorless, and also rate of diffusion. This is the formula given here. Okay, the rate of diffusions. Okay, this is the answer. Okay, title with correct unit, 1 marks. Okay. The title must write with the unit. Data recorded correctly, 1 marks. Transfer of data must correct. Okay, this one, if you write 1 decimal points, you must hold 1 decimal points. Okay, if you write 2 decimal points, your answer must hold 2 decimal points. Don't mix it up. Okay, and then calculation rate of diffusion correctly, 1 marks. This is 1 marks calculations, 1 marks. So you get 3 marks here for data. Question E2. Use the graph paper provided to answer this question. So you need to draw a graph of rate of diffusions, again ratio of the total surface area per volumes. So this is the answer. Okay. Both axes must label in uniform scales, and then all points correctly plotted. Okay, must plot all the points. Okay, and next one is smooth curved line and join all the points. All the points must be joined. We must use pencil to draw a lines. Okay, don't use ruler. F. Based on the graph in 1E2, state the relationship between the rate of diffusion and ratio of the total surface area per volume. Explain your answer. So relationship based on the graph, 1 marks. The bigger the ratio of the total surface area per volumes, the higher the rate of diffusions. Okay, this is based on the graph. And then give reason. Size or volume of agar decreases, and then the time taken for agar cube to become colorless is shorter. So this is the simple answer. The bigger the ratio of the total surface area per volume, the higher the rate of diffusion because size of agar cube decreases. So the time taken for agar cube to become colorless is shorter. Okay, or you can write like this. The bigger the total surface area per volumes, the higher the rate of diffusions because the volume of agar cube decreases, causing time taken for agar cube to become colorless is shorter. G. Based on the result of this experiment, state the operational definitions of rate of diffusions. For this question, you cannot give general definitions of rate of diffusions. You must refer back to the experiment, how the experiment is conducted, and then use all the apparatus and material in these experiments to explain or give definitions of rate of diffusions. Okay, definition must, which can be measured. For example, process of movements of hydrochloric acids into the agar cube per minute or per times. Okay, and then how it determines or shown by, okay, by time taken for agar cube to become colorless, and then affected by what, influenced by what, and the MV is ratio of the total surface area per volumes or size of agar cube. Okay, this is a simple answer. Rate of diffusion is the process of movements of hydrochloric acid into agar cube per minute that is determined by the time taken for agar cube to become colorless, affected by size of the agar cubes. Okay. H. Another group of students has carried out the same experiment by using a 20 millimeter agar cube. The agar cube was cut into 8 parts of the same size as shown in diagram 1.3. Predict the time taken for the agar cube to become colorless. Explain your predictions. If you notice, this size is same as agar cube K in our experiments. Okay, so for this question, you must give correct predictions. So the prediction is time taken is 9.9 minutes, or same as K, because the agar cube is the size when cut into 8, the size is same as K, if you notice it from the questions. And then the size or volume of agar cube is smaller or small, or just say same as K. And then total surface area to volumes increases or same as K. And then rate of diffusion is high, increase, or same as K. The rate of diffusion is same as K. And then the simple answer is time taken for agar cube to become colorless is 9.9 minutes because size of agar cube is smaller. So rate of diffusion is high. Question I. Diagram 1.4 show different surface of diffusions P, Q, R, S, and T in several organisms. Classify P, Q, R, S, and T into high rate of diffusion or low rate of diffusions in table 3. Okay, based on the volumes of the organisms, P, R, T are high rate of diffusions. Okay, because the total surface area to volume ratio is high when the volume is small or size is small. Law rate of diffusion is Q and S, okay, based on the total surface area to volumes and the size of the organisms. SPM 2019, question 2. MRF, self-service laundry shop, provide washing powder Y for their customer. Washing powder Y contain a type of enzyme that help the washing process, as in diagram 2.1. Enzyme is a type of catalyst which speed up biochemical reaction. Diagram 2.2 show three t-shirt P, Q, and R with lipid stains. The t-shirt were washed using washing powder Y at three different temperatures. Okay, t-shirt P with temperature of water 28, t-shirt Q temperature of water is 60, t-shirt R temperature of water is 37 degrees Celsius. Okay, if you notice here lipid stains, so the washing powder must be enzyme lipase. Okay, the question is, based on diagram 2.1 and diagram 2.2, design an experiment in the laboratory to study a factor that affects enzyme reactions. The planning of the experiment must include the following aspects: problem statements, hypothesis, variable, list of apparatus and material, procedure of the experiments, and presentation of data. Problem statements. This is from questions. Diagram 2.2 show three t-shirt P, Q, and R. This is operating manipulated variables. With lipid stains, this is constant variables. The t-shirt were washed using washing powder Y at three different temperatures. So this is operating manipulated variable. Based on diagram 2.1 and diagram 2.2, design an experiment in the laboratory to study a factor that affects the enzyme reactions. This is RV, responding variable. So the manipulated variable is different temperature based on the questions. Or you can write 60, 37, and 28 degrees of Celsius. This one in the table in the questions. RV is enzyme reactions, or you can write lipase reaction also can, because the stain is lipids, so the enzyme must be lipase. Okay. And number 3, relationship between the variable in question forms. Okay, must write in question forms. Okay, the simple answer is, what is the effect of different temperature on enzyme reactions? Okay, based on the MV and RV. Example number 2, what is the effect of different temperature on the rate of lipase reactions? Okay. Hypothesis, able to state a hypothesis relating the manipulated variable to the responding variable. So the manipulated variable is temperature, or 60 degrees Celsius. This one is considered as hot water. 37 degrees Celsius is warm water. 28 degrees Celsius is cold water. The RV is rate of enzyme reactions or rate of lipase reactions, or you can write activity of enzymes. Relationship between the variable must have relationship between MV and RV. This is the simple answer. Enzyme reaction is the highest in warm water compared to cold and hot water. Okay, you must compare it. And then sample answer number 2, the higher the temperature, the higher the rate of lipase reactions. Okay. Number 3, in warm water, activity of enzyme is higher as compared to cold and hot water. You must compare with these two. In 37 degrees Celsius, activity of enzyme is higher as compared to 60 degrees Celsius and 28 degrees of Celsius. Variables, able to state all the three variables correctly. So manipulated variable is temperature, or you can write warm water, hot water, and cold water. You have to write all. And then you can choose degree of temperature of water, 37 degrees Celsius, 28 degrees Celsius, and 60 degrees of Celsius. Responding variable, choose one only, cleanliness of cloth or cleanliness of t-shirt, or you can write size of oil stain after 20 minutes, time taken for oil stain to be removed, and constant variable, concentration of lipase or concentration of enzyme, concentration of lipid or type of washing powder used, quantity of washing powder, type of t-shirt, and volume of enzymes. Apparatus and material. Able to list all the apparatus and material correctly. So this is the sample answer. T-shirts, cloth with oils, washing powder, basin, bucket, beaker, brush, kettle, Bunsen burner, scoop, thermometer, washing powder, Y, water, oil, lipid stands. Okay, lipid stands, washing powder, thermometer, t-shirt must have in the apparatus material. Compulsory this one, because this one is in the questions, so you must write it. And then when you write the apparatus material, don't separate apparatus material in different group, but you must write like this, okay? Just make it, okay? Procedure of experiments. Able to describe the step of experimental procedure or method correctly based on the following aspects. So when you write the procedure of experiment, you must have 5K. So K1, K2, K3, K4, K5. Okay. So K1 is preparations of material and apparatus. K2 is operating the constant variable. K3 is operating the responding variable. K4 operating the manipulated variable. K5 step to increase reliability of result or accuracy of result, or step to for equations. Okay, this is the rubric for procedure of experiments. This is based on experiment using the t-shirts. Okay, this one is procedure. Later on we see the procedure. So for K1, only 3 steps only enough. Okay, counted as K1. K2 only once. K3 only one enough. K4 once, and K5 also once. So if you have 3 K1s, 1 K2, 1 K3, 1 K4, 1 K5, so that is enough. 5K, so you get 3 marks for procedure of experiments. Okay, let me see the procedure. Procedure of experiments. Experiment using t-shirt. Step number 1. Prepare 3 t-shirts with lipid stains and label them as A, B, and C. So prepare 3 t-shirts is K1, preparations of material. With lipid stain is K2, preparation of constant variables. We only use lipid stain in these experiments. Step number 2, pour 5 liters of clean cold water into a basin or washing machine. K1, K2, and K5. K5 is clean water to increase the accuracy of experiments. Add a scoop of washing powder Y into washing machine or basins. Soak t-shirt A in a washing machine or basin for 5 minutes. Okay, 5 minutes is K2. Okay, step number 5. Switch on the washing machine and let it wash for 30 minutes. 30 minutes is K2. Okay, preparation of constant variables. Okay. Number 6. After 30 minutes or 3 minutes, take out the t-shirt. This one is K1 and K2. Observe and record the cleanliness of t-shirts. This is considered as K3. Okay, operating the responding variable. Okay. Okay, step number 8. Repeat step 2 to 7 by using different t-shirt and water temperature. This one is K4, operating the manipulated variable. And then record all the data in the table. This is K1. So in this procedure, you already have 5K. Okay, so you can get 3 marks. Okay. Presentation of data. Able to present all the data with unit base on the following aspect. Correct manipulated variable with unit and data. This one. Okay, manipulated variable and then with data. Correct operating responding variables. Okay, with data. And then with the operating responding variable. Okay, so you can get 2 marks for this presentation of data. That's all my sharing for you today. So I hope you success in this coming SPMs. So see you next times. Bye bye.